This is the CNC Router Tips Podcast, episode 22. The computer sends out a signal, the electronic picks it up, translates it, sends it to the motors, and the motors move the motion system. This is the CNC Router Tips Podcast, a show which answers one question from you, the listener, about CNC router tables, CNC software, hardware, web hosting, and business. I'll help you get started in your CNC hobby or business and help you cut through the confusion.
Today's episode is sponsored by themakersguide.com. The Maker's Guide. Useful tools for makers.
Hello, everyone, and welcome to CNC Router Tips Podcast. This is our first episode for 2016, and I'd like to welcome everyone here who's listening to this episode, and thank you for being here. Starting a new year is always an amazing adventure, because when the year is new, anything is possible to achieve in that year. And, you know, traditionally, many people will make resolutions at the beginning of a new year about things that they want to do and things that they are trying to accomplish. You know, maybe you're trying to lose weight this year, or you want to start a business, or whatever those things are that are, you know, the hot button for you for this year. People tend to make resolutions, and one of the problems with that is most people don't carry out those choices that they make at the beginning of the years. And so a lot of resolutions never are stuck to, and they just aren't accomplished. So you might want to think, instead of making resolutions this year, maybe you should try making a goal. The goal is different from a resolution, because a goal has a specific objective and a specific time frame in which the object of that goal is accomplished. And it also has a specific set of circumstances that will exist, or a specific amount, or a specific thing that must be accomplished in order to meet that goal. And the reason that they're different from resolutions, most resolutions are like this: I'm going to lose weight this year. That only takes into account a couple of the things that you would need to do in a goal. You know, you stated what your object was, but you didn't state when. You stated what your object was, but you didn't say how much, etc. So, you know, maybe it'll be helpful to you to set goals this year. Give it a try. You never know. Now, on to CNC-related stuff. Today's going to be an episode that just talks about some of the basics of CNC. It's a new year, and we've got a lot of new listeners. I see our listening statistics are going up, so I can't assume that everyone who tunes into the show knows much about CNC. So I'm going to just take a little time and cover some of the basics, and try and give you an idea of what goes into a CNC machine. So one of the first questions you always hear when you mention to someone that you're doing something with a CNC router is, well, what is CNC? That's a question that's pretty easy to answer. CNC stands for Computer Numeric Control, which is just a fancy way of saying that a computer uses a series of numbers to control a bunch of motors. Well, every CNC machine has four things in common, and those four things are what characterizes a computer numerically controlled system. So rather than overwhelm you with a lot of details on that, I'll just break it down into a simpler form that anyone should be able to understand. So, what are those four things? Well, the first thing in CNC is the computer. And a computer is used to provide a signal for the CNC machine. And the computer is usually connected to a control box by either a parallel port or a USB cable or in some other fashion. And that computer just sends signals back and forth to another part of the machine. And every CNC has a computer. It's either internal or an external, like a PC. So, they're all the same in that respect. And what those computers controls are the motors. And the motors are the other thing that all CNC machines have in common. The CNC machine will, most of the ones that I'm familiar with have stepper motors, but they could also have servo motors, which are, a different kind of motor. And a stepper motor is a special kind of motor that can move in extremely small increments and very precise manner, versus a servo motor, which is just a regular direct current motor, which can spin very fast, and its position is controlled using some additional parts called encoders, which send signals back to the computer and the control system to tell it to stop. So we're not going to deal with the servo motors. We are mostly dealing with stepper motors. Now, the computer and the motors, they all have to work together to move parts. And the third part of what every CNC machine has is a motion system. And that can be some form of precision ground rails or guide rails and bearings that allow the moving parts to slide smoothly. And there's a lot of different kinds. There are many ways that people can come up with this, from the simplest thing down to, drawer slides that you would use in shelving, for really inexpensive ones, all the way up to ball bearing linear guide blocks. And, that's all the motion system does, is make things slide smoothly. The fourth component is the electronics. And I lumped a lot of things together in this category because in a CNC machine, there's a series of boards and relays that receive signals from the computer and translate them into signals that the motors can understand. And the electronics then send signals to the motor, and the motor moves. So it's pretty simple. The pathway goes something like this. The computer sends out a signal, the electronic picks it up, translates it, sends it to the motors, and the motors move the motion system. There you have it. That's the basic breakdown of what is in every CNC machine. And when I say CNC machine, I'm not just limiting myself to CNC routers, because you can combine these four components into a variety of ways. All of these components can be combined into a variety of different ways to control machines. And there's a lot of different types of CNC machines. There's a type we're familiar with, which is the CNC router table. And that's usually a large flat surface or table, to which you secure your part. And then another type of motor called a router moves a spinning bit, which then cuts into the wood. Okay. There's also CNC milling machines, which are typically used for metalworking. And, they're big, 6,000 or 7,000 pound machines, which can machine aluminum, make car parts, steel, brass, any of the metals. They typically have a smaller work area than a CNC router table, but they're much more rigid, so you can get much more precision and, better surface finishes from them. There are also CNC lathes, and the best way to explain a lathe is that it makes round things like a wheel or an axle or a chess piece or a pen or something. They do this by spinning an object that's mounted in a chuck, and then a cutter comes along and removes everything that is not the part you want finished. So it's essentially spinning off a fine chip from the edge of the part to give you a round part. There's also CNC machining centers, which can combine the features of a milling machine and a lathe all into one big machine. These are typically used in high-speed machining and production, and they're sort of a hybrid machine. You can perform a milling operation and some of the turning operations of a lathe all in this one machine, and they typically are extremely expensive and only used in industry. Now, for those who like to make model aircraft or even full-size aircraft, there's another type of CNC machine called the CNC foam cutter. And I say foam, F-O-A-M, and I mean styrofoam or extruded polystyrene or insulation type foam. And essentially what this is it's a 4-axis machine that uses a hot wire or a heated wire to melt the foam into its final shape. And it can make pretty much any conical shape out there, like an airfoil or a traffic cone or that sort of thing. A lot of times these are used by home-built aircraft people, to make their own airplanes, and they or to make molds that go with fiberglass and resin. So that's one type of CNC. And last is probably the newest addition to the group is the 3D printers. They're also CNC machines. And a 3D printer typically heats up some material and extrudes it or squeezes it out like a tube of toothpaste, a thread of this heated material onto a platform, and build up layers and layers and layers of this material until they've got to the final shape that you're looking for. And if you were guessing as to what the hot CNC item is, it would definitely be the 3D printers, because they're appearing everywhere and the prices are going lower and lower. And many people who have CNC router tables also have 3D printers or want to build one. And, realistically, you could convert your CNC router into a 3D printer fairly easily if you wanted to. But the cost of the 3D printers is so low now, it's probably a waste of your time. So those are just a few of the types of machines that are controlled using CNC control. There are also machines that are strictly for cabinet making and edge banding, processing raw lumber, many other things. But, the ones that we've mentioned are probably the most common. Okay, a few years ago I started writing a book about CNC machines, and I got quite far into it, and where there was a lot of chapters and a lot of different things written about it. And at the time, CNC router tables really hadn't caught on with the general public, so there were a few manufacturers of commercial machines, and there were a lot of kits available where people were making their own. But there really weren't any inexpensive desktop-size machines or, anything under 4 foot. They just weren't there. That hadn't happened yet. But now we're in a situation where there's a lot more available. I mean, there are many off-the-shelf machines that you can buy. And, there's, at one point even Sears was offering a CNC machine that I think it was called a CompuCarve or something similar. It looked like a wood planer, and then instead on the side you'd insert your wood, and out the other side would come your completed project. That was kind of one of the machines that kind of sparked things to accelerate. There's another machine, the CNC Shark, that Rockler Woodworking is now carrying. At first it was out directly from a company, and that one was made mostly of plastics and some aluminum, and has now grown into many different varieties. And a lot of people have gotten their start with it. Another company that came along was Cam Master, and they came out with a machine called the Stinger, which was their entry-level machine, and it was quite robust, a big, stout machine. It's a very nice machine, still to this day. And, they had larger versions of it, like the Cam Master Stinger 2, which, is a mid-sized machine, like at least 4 foot in size for most of them. So it's fairly large. But, ShopBot was probably the de facto machine for the home CNC hobbyist. ShopBot came out with a couple of machines that were in the desktop size. First, they came out with the Buddy, which was, a shortened bed length machine with an extensible arm that allowed you to cut bigger pieces than you normally would in a machine that size. And those became very popular. And then they dropped down and they came out with a ShopBot desktop machine, which was, I think 2 foot by 2 foot in area. And, that was finally dropping the price of a CNC router below $10,000 for ShopBot. That was quite amazing. Some of the ones that I've mentioned earlier were already below that price point. But, when you look back in the time, ShopBot's been around for 20 years plus. So, for them to come out with a little desktop machine that was affordable was quite a coup. But, that was 5 years ago. And a lot has changed since then. And you've got other new players popping on the scene like Probotics. Probotics has quite a line of machines out there in a variety of sizes. I think they have 4 or 5 different sizes, Meteor, Asteroid, and a few others in their line. And, they're nice, well put together machines. And you've got Stepcraft. They were just on our show just a few episodes ago. They also have come out with quite a few small desktop machines. They go from one that's about a foot in cutting area all the way up to one that's about 4 foot in cutting area. So, they're a new player on the scene from Germany. Pretty nice machines. X-Carve, the folks from Inventable, they had both the X-Carve and the Shape Oko. Those were 2 spin-offs from a project that was a Kickstarter project that Bart Dring masterminded, where he decided he wanted to make his own aluminum extrusion that would be suited for making small CNC machines. And once he did that, Shape Oko and X-Carve and a few other machines using that extrusion came into existence. And now since then, both Shape Oko and X-Carve have developed their own extrusions, which are, specialized and stronger. But they're coming out, and a lot of guys are getting started in CNC using the X-Carve or the Shape Oko. Well, one thing that is kind of unique about both of those is they don't use a traditional controller, CNC controller that most of us are used to, that is dependent on a computer, a standalone computer to run. They are Arduino based, and Arduino is a little microcontroller that a lot of maker devices are made of. They're in 3D printers and everything. That you load the information into them once, and then from that point on, they're ready to just perform their job as a CNC controller. You plug a thumb drive into them and load your file and go ahead and cut. And in some cases, you can do that without the computer being plugged in to the machine while it's going on. That's good, and it's bad. The good part is it is an inexpensive way to get into a CNC machine, and it is a good way to produce products. One of the downsides is if you intend to use that equipment to build a bigger machine later, it may not be as suited as if you had your own standalone controller box. And, so there's expense there. There's no wrong answer. These are good machines. I'm not trying to say otherwise. It's just something to be aware of in your path, because most of us start with a small machine, use it for a while, and then decide to move up to something larger. So that's one thing to think about. Another company that's out there is Zen Toolworks, and I haven't personally seen one of these up close, but I've seen them advertised on Amazon, and they're a machine that is made out of plastic material, and I think it's PVC or acrylic. I'm not certain, but the thing that is attractive about the ZenBot Toolworks machines is that they are very inexpensive to buy, and it's a kit. You put it together, and just like any of these other CNCs, it's going to work, and it'll get work done. I wish I could tell you more about it. I just know that it's out there. And there are probably dozens and dozens of other things that are out there. There's all sorts of machines that are being imported from China on eBay that, I have not seen, but there are a lot of people who have them, and some are having very good luck with them. So there's a lot out there. Take your time. Go research what it is that you want to do and what you need to do, and then you can pick one. I mean, there's so many good machines out there now that it's really getting hard to make the argument to build your own machine unless you have a specific need. And to me, I love building machines, and I enjoy it, and it makes a lot of sense. I get exactly what I want and the size I want and everything. But it is a time, there's the time involved in waiting and trying to build your machine yourself. Time that you could be cutting with a machine that you purchased, off the shelf. But I know that there are very few machines on the shelf that I'm satisfied with, so I build mine. But that's just the nature of me. I'm a tinkerer. I'm a gadget guy. I like making things, and I like experimenting and finding out how things work, and that's just the way I am. So it suits me to build a machine. There are other machines that I would love to own, to have one around to play with and to make new projects on, and maybe one day I will. There's nothing bad one way or the other if you're building or you're buying. I mean, you're still getting a CNC, and that makes me happy and smile at the end of the day, because there's more people I can talk to about this crazy obsession that I have. Choose your own. Now, any discussion of a CNC router wouldn't be complete if we didn't talk about the software for just a minute.
Today's episode is sponsored by The Maker's Guide, creator of the Triple Edge Finder. Get the edge you need, save time and frustration on your CNC project, and make setup a snap. Save time and material. Set up your workpiece on your CNC router table faster than ever. Accurately set your Z-axis height first time, every time. Automatically locate the corner or edge of a workpiece. Reset your starting point in the middle of a program. Quality crafted right here in the USA on US-made CNC machines. Get the edge you need today. Go to www.themakersguide.com/edge. The Maker's Guide. Useful tools for makers.
Now, any discussion of a CNC router wouldn't be complete if we didn't talk about the software for just a minute. And, since I'm assuming that you're new to the CNC world because you're listening to this right now, you might not know that there are 3 types of software that you need to run a CNC router. But there are 3. There's a drawing program, and a drawing program can be any kind of CAD package, or in some cases a graphics program like CorelDRAW or Adobe Illustrator or Inkscape. The thing that's important to consider when you're getting a drawing program is that it can produce vector artwork to a specific size, and it needs to be able to do that. The second type of software that you need besides the drawing program is a CAM program. Now, CAM stands for Computer-Aided Machining, and it is the software that generates the tool path from your vectors. And the tool path is the path that your cutter will follow, when the motors are moving. So a CAM package converts vector drawings into G-code format so that the software driver for the motors can read it. And the third piece of the puzzle is the motor driver program. And that takes the G-code that was produced in the CAM package, which was created from the vectors that were produced in the drawing package. And it takes that G-code provided by the toolpaths to generate step and direction commands, which allow the electronics to move the stepper motors. So it tells it, take a step forward or take a step backwards. That's basically all it's doing. So it needs those two signals. How many steps do I go and in what direction? And that is provided to the motor drivers in the form of G-code. So there are many choices for these, three types of software. Everybody's got their own favorite, and several programs, that are written in open source. There are several that you can buy. It really doesn't matter what you use. There are many great ways to get it all done. In fact, there are some programs that combine more than one part of each of these. For instance, Vectric VCarve Pro or Cut2D combines a drawing program and a CAM package. So it can create the vectors and it can create the G-code. Then you would use another driver software like Linux CNC or Mach 3 to cause the motors to move with that kind of package. So there's a lot of packages that combine two out of the three, but I know of very few programs that do all three functions. Just be aware of that when it's time to make your budget up for what you're going to get. Okay, hopefully this has helped you try and understand a little bit more about CNC router tables and what goes into them and the parts that you need and the software that you need. At least it'll give you a clue when you start doing your Google searches and looking around to see what's out there, what you're looking at. And particularly with the software, it's hard to tell what the software will do for you. And, you might look at a package and say, oh, I can afford this, and then find out that you need to buy two other pieces of software, and now your budget is broken. So at least now there are three types of software and many types of CNC routers, and that each of them have the same four basic components in them. So I hope that was helpful. Say one last thing before we conclude this episode. I'd just like to give a quick shout out to the members of the CNC Router Tips Facebook group, and in particular, I'd like to thank everybody that helped to grow this group, because it's been growing very fast. We started last February, and as of today, we have 2,053 members in our community. And that's phenomenal growth from, 0 in February to this. And the majority of that growth has been since August. We were at 1,000 members in August, so we've doubled since August, which I think is truly amazing. And as I was looking through the stats on the Facebook group, I realized something. We've got people from everywhere. And one of the countries that surprised me, we have a large number of our members from Brazil. And, I don't know, I don't know what's driving that. I think it's fantastic. I'd love to see Brazil sometime. I've never been. It sounds like a blast, but apparently there's a lot of activity in CNC down in Brazil. So I'd like to give a shout out to all the members of the CNC Router Tips group from Brazil. Hey, leave me a note on the forum. I'd really love to hear from you. Maybe next week I'll shout out to one of the other groups that's presence is being felt. We've got a lot of Australians on there too. So I just wanted to say thank you to all the folks here from Brazil. I often mention many different types of software during the episodes, and hardware and cutters, and it can get a little confusing. So what I did was I put together a page on my website, cncroutertips.com/resources. And on that page, I list all sorts of resources there, from books to tools to software, all the things that I use that make my CNC experience better and easier. And I hope you'll check it out. So again, it's cncroutertips.com/resources. Now, if you'd like to have your question featured on the air, here's how. Need help? Ask me about your CNC router question on my podcast, the CNC Router Tips Podcast. I'll be glad to help or try and get you the help you need. I want this podcast to be a fun and personal experience for everyone, and helpful. So let's keep it real and ask sensible questions. Please use common sense and show courtesy to everyone. That way everybody wins. Here are some guidelines to ensure that your question is qualified to be featured on the show. Please keep your questions under 1 minute in length. If it goes a little over that, that's fine, but don't ramble. If you have a website and URL, you're allowed to share it, but only once during the recording. Spammy or disrespectful or deeply private questions will not be considered for the podcast. If you need to ask more than one question, just make each question a separate voicemail. Thanks again, everyone, for tuning in and listening to the CNC Router Tips podcast. If you'd like to join our free mailing list, you can go to cncroutertips.com, and there's a link right there on the top of the page which tells you how to do that. Thank you so much, and have a great day.